This program, SHOWJPEG, shows the effects of DCT matrix quantization and chrominance subsampling on the image quality of a JPEG. Before describing how the program works, let's look at how the image is processed. This picture shows a basic block diagram of the JPEG encoder and decoder. The encoder starts with a standard 24-bit per pixel PNG image comprising red, green, and blue color channels. The image is first converted from the RGB color space to the luminance and chrominance space, and the chrominance is optionally downsampled. The luminance and chrominance channels are separately processed with a DCT and quantized using standard quantization matrices that permit the amount of quantization to be adjusted by a quality factor. The DC matrix components of these matrices are differentially encoded, the AC components are run length encoded, and all the data are then entropy coded using standard Huffman tables into a final compressed bit stream. Returning to the program, you first select the input PNG image from the File menu. The input image is shown in the left panel, the output compressed image is shown in the right panel. Because all processing is done in MATLAB, it can be pretty slow to see the output image. The quality factor, Q, which determines the amount of quantization of the DCT matrices, can range from 1, which gives maximum quantization and poorest image quality, to 100, which gives minimum quantization and the best image quality. The default value is 50. By default, the chrominance is not downsampled. That's called 444 sampling. But you can choose to downsample chrominance horizontally by a factor of 2, that's 422, or downsample both horizontally and vertically by a factor of 2, that's 420. The text above the image on the right shows the amount of compression of the JPEG relative to the PNG at the selected quality factor and chrominance subsampling values. For example, given values of Q is 50 and 444 chrominance sampling, you can see that the luminance channel is compressed by a factor of more than 16 to less than half a bit per pixel. The two chrominance channels together are compressed by a factor of almost 50. The total compression is about a factor of 30. To show how quantization affects details of the image, you can zoom in on a portion of the input image and see the effect on the output image. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.